Good day, everyone. This is Gabriel again, and welcome to the third episode on our tutorial on all things CEMENTO. So, for people who might not know, CEMENTO is a package for converting your Draw.io ontology diagrams into turtle files and vice versa. And if you want a more in-depth introduction into its features, feel free to watch episode 1 of this series where I go into depth into what CEMENTO can do. For this episode, we're continuing of what we did in the last one, where we created a Draw.io diagram from the ground up. And so if you're following along and you've skipped a couple of videos, please watch this in the series. It will help you a lot. But just to recap, nope, nope. We have here draw tutorial, which I drew in the last episode, where we have a model for different types of vehicles, and it just says that Gabriel is a person and I'm driving a Toyota Camry. So, and this also demonstrates you could do literals, you could do type annotations and the like, and also multiple inheritance. So if you don't have this file yet, feel free to just recreate this, rate this. This is a very simple diagram. And once you have this, you'll be able to follow along for this episode. Because for this episode, I will work on files that I showed you just prior, I think by accident, called bad reference. And bad reference is the same as the file that we drew, but has a different set of problems. So here you have driver. You see the subclass of is disconnected to person, so it doesn't have an object. You see here that both driver and Gabriel are disconnected, so this arrow right here is floating. It doesn't have a subject or an object. In here, for transportation artifact, subclass of does not have a subject. And here, as I've shown prior, we have unlabeled connectors and unlabeled terms. So what CEMENTO does is it highlights these errors for you. So let me just show you how to do that. So this is the error that I ran previously, but for the sake of example, I will run it again. So if I go about my day writing this command, I did bad reference, IO bad reference turtle, I enter that expecting it works, but it doesn't. And this output is very important for you to fix the errors that are present in your diagram. Now, this error checking doesn't guarantee that all errors will be covered, and I will explain what those errors are, which I kind of think about as invisible errors that also have their degree of criticality. But in this particular case, these are the errors that you can start fixing. So what does this error actually say? It says that bad diagram error, the diagram has several syntax issues that needs to be resolved. Please refer to generated file at bad reference error check.io. Problematic elements are in red. Refer to earlier output for list of errors. So this earlier output is this list, and it says that we have to check bad reference error check. So that's what we're going to do. If you go back to Draw.io and open error check, you will see that all of our problematic elements are in red. Now, as I've discussed before, some lines are exempted, and I think the check needs a bit of refinement, but this won't be part of your ontology, even if this passes, right? So now I have a different set of errors that I need to fix one by one, and let's go ahead and fix it. So if I have a CCO person that's a disconnected object, all I have to do is connect it like that. So the problem right now is that CEMENTO will not revert this to its original color. So I think we'll just go ahead and do that ourselves. The assumption, of course, is you'll be able to fix everything in a few iterations, but in a bit, I'll show you what you could do to iterate over it. So here we have red as well. We want it to turn black, and you have it back to normal. In this case, if we wiggle it a little bit and see it's connected, we're good. Now, as I've mentioned in the last tutorial, important to keep in track of end arrows and start arrows, we want end arrows. And we want end arrows that point the right way. Because again, as I mentioned before, Draw.io will sometimes reverse these, and it will look correct, but it's actually incorrect. So just to keep in mind, right? This end arrow is what matters. So I fixed one error. Let's keep going. This one needs a subject, and this isn't in red because this is technically correct. It's an object to something. So if we link that again and do what we did before, we have fixed another set of errors, and we can keep going. Oops. There you go. So now, how about these terms? So these terms might come up whenever you make an ontology from scratch, and you were trying to create a subgraph for that ontology, but forgot all about it, and this will be in red. And the reason I highlight this as an error is very simple. It's because we want our diagrams to represent almost one-to-one what we want the tutorial files to be. And that way you get controvertibility, right? It's a complicated way of saying you can convert one format into another in a way that's meaningful. So last error, and we are good to go. So let's go ahead and save this and run our command again. Now you see this didn't really help at all. It looks like the syntax issues never got fixed. So this will be a very common error that you'll encounter. You'll think you already fixed everything, but it didn't really parse through. And there's a simple reason for that. It's because if you look at our dry diagram, we're back to normal. And that's because we did our changes in error check rather than in the actual ontology file, which is in bad reference. So if we do the fixes here, it will pass. But let me show you that it actually works. And you can see here, this file doesn't have highlighting, but we knew from the previous error check diagram that these are the problematic elements. Also, it's very obvious from us because this is a small ontology. You could see that these were disconnected as a simple fix. Again, just to check that the arrows go the right way, check, check, and we're good. So now this should be fine. And hopefully, when we run our command again, it passed the diagram errors and it doesn't complain. And we got where we got before. So now, what if you had a very giant diagram that you had to iterate over just for the sake of sanity? Well, to do that, all you really have to do is pass the check error file instead. All right, so that's error check. Okay, so there's a reasonable question to ask is why not just directly operate on your file? And it's because we want to maintain a version of your file that's kind of pristine. And that way, when you check your errors and see everything's fine, you'll still have your original version of the diagram. So instead of directly running it iteratively, we kind of make a fork in the road and just decide to edit this file instead, and this error check. And if we run this, you will see obviously it will have problems. That's because it was generated from our previous file, right? So now we want to fix this file instead of the original. We do the same thing. So just for the sake of brevity, we'll skip over formatting them again, although it's good practice to always format them to the defaults. This is just part of the trade-offs for working on a bad reference error, right? So once we run this, as you can see, it passes and it's not complaining anymore. Mission accomplished. So before we call it a day though, I just want to point out that some errors might be so obscure just because some of the labels are small or you're crisscrossing too much. And if you see here, you barely could see that the relationship between vehicle and transportation artifact is actually a problematic connector. So how do you debug if that's the case? So we recommend you put a lot of space in between your terms just so it's easier to see. But if it's really unavoidable and you really want to be able to just debug in this way, there's also an easy fix. So let's say we disconnected this by accident and we're shrinking it like that. So now it's completely covered and now you don't know where it is. So if I run this, let me just correct the format here. I think that would work to our favor. Yes. Go back. Okay. So go back to our VS Codium and you see it's still complaining. But watch, these terms will actually tell you where that errant element is. And in this case, it says that the term with content CCO transportation artifact is not connected to any other term. So it's a floating term. The second one, edge with ID blah 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 33 and content RDF subclass of and with child CCO transportation artifact is located in 360.250 and it doesn't have a source parent connected. So all of these error outputs above actually have enough information for you to locate and distinguish which elements are actually causing the error. In this case, we know it's subclass of, but if you didn't know, we could use three things. We could use the fact that it's connected to CCO transportation artifact, and since if you like this diagram, this is much bigger, we know that this is where the problem might be. We could also use location, and this is also crucial when you're trying to debug very tiny things or crisscross connected things. And it says that the edge is actually located in 360.250. What does that mean? What that means is it's located in 360x and 250y based on the coordinate system of Draw.io. And Draw.io is a weird coordinate system like any drawing application where y goes this way instead of up and x goes this way. We would have preferred if it was the same. That way we don't have to do transformations when computing things. But you can activate the ruler to help you using view ruler. You can toggle that on and off. By default, it won't be there, just so you know. Now, if you go back to our error, it says that it's located in 360 and 250. So let's do that. 360 is right about here. 250 is right around here. And we see that, yeah, this is where the actual error is. And now we can proceed to fixing this error. So do the same thing we did before. Right? And now, if I run this, it should stop complaining. That's it. Now if I check the bad reference error check, we called it bad reference.turtle. You can see we have a similar output as the one we had in the previous episode. And now we're able to parse all of these terms. So the terms that had problems, transportation artifact, it's still here. That means we managed to fix the errors. So good, right? We can call it a day. Well, not quite. These are the errors that are very obvious, that are programmatically possible to locate, but they're subtle errors that you'll only be able to catch within your output. And one of that has to do with the end arrows and start arrows I keep on mentioning. Now, the reason I emphasize that over and over again is very simple. It's because if you have an end arrow like so, right? And this looks correct. What it actually says to CEMENTO is that take this transportation artifact and say this is a subclass of vehicle, which is absolutely incorrect. And if this error propagates all the way to your documentation, all the way to your instantiation, that would be very problematic. So there's one way to solve this, which is by adopting good habits and making sure this is end arrow star arrow. Now we will be adding normalization in an upcoming release, just so you don't have to do this manually. But while you're trying out our package, especially if you come from the symposium, this is something to keep note of. Yes, and this will solve you a lot of problems. This will save you a lot of time. Just keep that in mind. Now, another way to debug this is obviously to go to VS Codium and to just check whether or not your outputs make sense. Now, this is more difficult as your graph grows, but that's just part of the deal, right? CEMENTO only makes this process faster, when in reality, this is the level in which we operate. These are the actual statements that we actually rely upon. And if there are problems, it might be more prudent to resolve them through the text editor, and in this case VS Code, than it does for the diagram. It completely depends on you, how you prefer to debug. Now that you know how debugging works in CEMENTO, you can go ahead and create your diagrams with confidence. My best hope is if you do find issues that are related to the package, the first thing to check is the FAQs. We have sections for package installation, usage. You can see some of the common errors that I mentioned here. Packages complain about non-ontology elements. How do I add axioms and restrictions? I get the same errors when running the program again. This is the exact same thing we discussed. Another thing is inaccurate outputs. This is where some of the terms get reversed, and these are simple solutions. You can see I give the advice I always give on these tutorials on this same page. All right. So if you really think that CEMENTO is messing up and you really want the fix, you can go ahead and go to the bottom part to see how to submit an issue. And if I click on this link, you will see that there are currently no issues, but you're free to create an issue like so. And if you write a description here, we do recommend you attach the inputs you provided, and if those inputs cannot be provided, feel free to make a contrived example that reproduces your error. So we do ask you to be respectful, please be specific, add your system information if you think that's relevant. And we will get back to you and we will create fixes. Thank you for your cooperation. That's it for diagram checks. And the next episode, we'll be talking about the other way on converting turtle files into draw.io diagrams. And this will be a quicker section just because drawing is a much easier task than it is converting. But we'll have a set of features that might get you excited on making diagrams. Thank you so much, and I hope to see you in the next one.